In this video, I'm going to show you how to prove the laws of logarithms. So first of all, we want to prove the product rule. That is, for numbers n, a, and b greater than 0 with n not equal to 1, we have that the log base n of the product ab is equal to the log base n of a plus the log base n of b. So how should we start off this proof? Well, why don't we use a trick to simplify the situation a lot? Since n is some positive number that is not equal to 1, we can get any other positive number by raising n to some exponent. So that means we can let a and b be such that n to the a equals capital A and n to the b equals capital B. So we're just saying define lowercase a and b such that they satisfy these two equations. And we know for sure that there are such a and b because n is a positive number not equal to 1. So that means any other positive number, like capital A or capital B, can be obtained as some power of n. So using this definition then, we can say that log base n of ab, that's the left-hand side and what we're trying to prove here, that is equal to log base n of, well, a is just n to the lowercase a, so n to the lowercase a, and then b is n to the lowercase b. So inside the log, n to the a times n to b simplifies. Since they have the same base n, we can just add the exponents, so n to the a plus b. And log base n of n to the a plus b is just a plus b. Because log base n just asks what is the power that you have to raise n to get to this argument n to the a plus b. So just a plus b. Alright, so now you might begin to see where we're going with this. We have that log base n of ab, that's the left-hand side, is equal to this whole chain of equivalences, which comes out to a plus b. And this right-hand side, and what we're trying to prove, is also a sum. So really, we just need to show that lowercase a is equivalent to log base n of uppercase A, and lowercase b is equivalent to log base n of uppercase b. So let's go ahead and write that down. So since n to the a, lowercase a equals capital A, we have, taking log base n of both sides, that a equals log base n of capital A. And likewise, there's the same argument for b. So likewise, since n to the lowercase b is equal to capital B, we have, taking log base n of both sides, that lowercase b is equal to log base n of capital B. So now we're going to pull all of this information together. We know that log base n of the product capital A times capital B is equal to lowercase a plus lowercase b, and we also know what lowercase a and lowercase b are in terms of log base n. So pulling all of this together, we can say that thus log base n of ab, capitals, is equal to lowercase a plus lowercase b, which is equal to, substituting in this information, lowercase a is log base n of uppercase A, and then lowercase b is log base n of uppercase b. And then we're done. That's what we wanted to show. Log base n of capital A times capital B is equal to log base n of capital A plus log base n of capital B. So there we go. Next up, we want to prove the power rule. That is, for numbers a and x greater than 0 with a not equal to 1, we have that log base a of x to the n is equal to n log base a of x. And here n is just any general number n. So again, why don't we start this off by simplifying the situation a little bit? Why don't we let y equal the left side of our equation, log base a of x to the n. Now the reason we do this is that we can simplify this into an exponential equation. If y equals log base a of x to the n, then a to the y equals x to the n. So let's write that down. Then a to the y equals x to the n. Now what we're going to do is we're going to manipulate this equation a little bit. We'll start by raising both sides to the power of 1 over n. So a to the y to the power of 1 over n is equal to x to the n to the power of 1 over n. Now we know that when we raise powers to powers, we can multiply through. So this becomes a to the y over n is equal to x to the n over n, which is just x to the 1, which is just x. Now we can go ahead and take log base a of both sides. So on the right hand side we'll have log base a of x, and on the left hand side log base a of a to the y over n. That's just the power on the a, y over n. And then multiplying through by n, we find that y equals n log base a of x. And hey, look at that. This is the right hand side of the equation that we want to prove. So we see that y equals log base a of x to the n. That was our definition for y. That was the left hand side. And we found that y was equivalent also to n times log base a of x, which is the right hand side. So we can say that because both y equals log base a of x to the n and y equals n times log base a of x, we must have that log base a of x to the n is equal to n log base a of x. And that's what we wanted to prove. So we're good. We're all done. Now we want to prove the change of base rule. That is, for numbers a, b, and x that are greater than 0, with neither a nor b equal to 1, we have that log base a of x is equal to log base b of x divided by log base b of a. So any guesses as to our first step here? If you guessed that we're going to simplify the situation, you'd be right. And we're going to do this the same way that we've done previously. Let's just let y be our left side, which is log base a of x. And the reason for doing this is that we can turn this into an exponential equation. A to the y equals x. So then a to the y equals x. So that means we have a formula for what x is in terms of a and y, and we can sub that into this log base b of x, and we'll get an interesting result. So then log base b of x is equal to log base b of a to the y, and using the power rule, that's just the exponent on the a that pops out, y, then times log base b of a. So to recap that, we have that log base b of x is equal to y times log base b of a. Let's write that down. We have log base b of x is equal to y times log base b of a. And now we can solve this equation for y. We just divide by log base b of a. So we have that log base b of x over log base b of a is equal to y. And hey, look at that. That is the right-hand side of our equation that we want. So we've got our left-hand side and we've got our right-hand side, and we know that both of these are equal to y. So we can say that because both y equals log base a of x and y equals log base b of x over log base b of a, we must have that log base a of x is equal to log base b of x over log base b of a. And that's exactly what we wanted to show. So we're all good. So now we know not just how to use, but also how to prove the laws of logarithms. And really understanding the ideas behind these laws will be very useful to us in the future as we learn about logarithmic equations and logarithmic functions.